Welcome to section 13.1. This is the 142nd session of the CISSP exam prep series. In this session, we'll cover how you control access to the things an organization values. We'll answer several questions. What exactly counts as an asset worth protecting? What are the 6 technology asset types you must guard? How do physical controls protect them? How do logical controls protect them? And how does all of this map back to confidentiality, integrity, and availability? Why does this matter beyond the exam? Because access control is the daily work of protecting a business. Imagine a regional credit union. It has customer records, transaction systems, laptops, branch offices, a mobile app, and a print service. Every one of those is an asset, and each needs the right lock. When you can name what you are protecting, you can choose the correct control for it. That skill is what turns a policy into real protection. So what actually counts as an asset? An asset is anything of value the organization needs to defend. Some assets are tangible, meaning you can physically touch them, like a server or a badge reader. Others are intangible, like a customer database or a patented design. People are assets too, but our focus here is on the technology side. Think of it like a warehouse. Some things on the shelves are physical goods, and some are the blueprints that make those goods valuable. What are the 6 technology asset types you must protect? The certification groups them into a clean set. There is information, systems, devices, facilities, applications, and services. Each one is a different surface an attacker might reach through. If you can picture all 6 at once, you can audit any environment and confirm nothing is left uncovered. We'll walk through each one now, so the whole map stays clear in your head. What do we mean by information as an asset? Information is all of an organization's data, wherever it lives. That includes files on servers and laptops, records inside a database, data sitting in the cloud, and even paper in a filing cabinet. Logical controls are what keep unauthorized people away from it. Picture a law firm's case files. Whether they are digital or printed, the goal is the same. Only cleared staff get to read them. What counts as a system worth protecting? A system is any set of components that delivers one or more services. A single file server that hosts shared documents is a system. So is a web server paired with a database to run an online store. You control access to systems through the permissions assigned to user and machine accounts. Think of a system as a working machine on a factory floor. Only trained operators get the keys to run it. What are devices in this context? Devices are the physical computing equipment across the environment. That covers networking gear like routers and switches, storage arrays, servers and desktops, laptops, tablets, phones, and even printers and scanners. Many organizations now let staff connect personally owned phones and tablets. Here is the key point. Even on a personal device, the company data on it is still a company asset. So the phone may belong to the employee, but the sales figures on it belong to the business. What about facilities? Facilities are the physical places the organization owns or rents. That could be a single room, a full building, or an entire campus of buildings. You protect them mainly with physical security controls. Picture a data center. Fences, guards, and locked doors all exist to keep the wrong people from ever reaching the racks inside. Why treat applications as their own asset? Because applications are usually the doorway to your data. By controlling who can open an application, you add another layer of protection around the information behind it. Permissions make this easy, assigned to individual users or to whole groups. Think of an application as the front counter of a bank. Even before anyone touches the vault, the counter decides who gets to make a request at all. What are services and why guard them? Services are the capabilities an organization offers, like printing, network capacity, or end-user support. Access control systems make sure only authorized users can consume them. Imagine a shared print service in a large office. Without controls, anyone could route sensitive documents to any printer. With controls, only the right people reach the right output. So how do you actually protect all these assets? You use 2 broad families of control. Physical controls are the ones you can touch, like fences, gates, turnstiles, and even heating and fire suppression that guard the environment. They shield systems, devices, and facilities directly. A locked server room with a cipher lock is a perfect example. It protects the hardware, and by extension the data and applications that hardware holds. What do logical controls handle instead? Logical controls are the technical protections around information, systems, devices, and applications. They include authentication, authorization, and the permissions that follow. Only someone who can authenticate reaches the data, and permissions decide exactly what they touch. These same controls restrict who can change configuration settings on a router or a server, and they work the same way whether the resource sits on-site or in the cloud. How does all of this tie back to the core triad? Access control exists mainly to prevent loss, and there are 3 losses to prevent. Confidentiality means only authorized subjects reach objects, so an unauthorized read is a loss of confidentiality. Integrity means data and settings are not changed without approval, or that changes get detected, so an unauthorized edit is a loss of integrity. Availability means authorized requests are served in reasonable time, so an outage that blocks legitimate users is a loss of availability. Every control you place is really defending one of these 3. So let's bring it together. Assets are anything of value, tangible or intangible, and the technology set spans information, systems, devices, facilities, applications, and services. You defend them with physical controls you can touch and logical controls built from authentication, authorization, and permissions. And the whole point is to prevent loss of confidentiality, integrity, and availability. Master this map, and every access control decision later in the domain has a clear home. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session. Welcome to Section 13.2, Part 1. This is the 143rd session of the CISSP Exam Prep series. This part lays the groundwork for how systems recognize and trust the people and things that ask for access. In this session, we'll unpack the core model behind access control. We'll answer several questions. What are the 3 functions at the heart of identity and access management? How do identification and authentication work as a pair? What are subjects and objects, and why do their roles switch? How do you prove someone's identity when you first meet them? What do authorization and accounting add? And what are the 3 factors you can use to prove identity? Why does this matter beyond the exam? Because every login you will ever design rests on these ideas. Picture onboarding a new nurse at a hospital network. Before she touches a single record, the system must confirm she is really her, decide what she may open, and log everything she does. Get that chain right, and trust flows cleanly. Break one link, and accountability quietly disappears. So what are the 3 core functions of identity and access management? They form a model you will see everywhere. First, authentication confirms that a user, service, or agent is who it claims to be. Second, authorization decides which actions that entity is allowed to take. Third, accounting keeps an audit trail of what actually happened. Together, these 3 are known as authentication, authorization, and accounting. Think of them as a nightclub door. The bouncer checks your identity, decides which rooms you may enter, and the cameras record where you go. How do identification and authentication actually work together? They are a 2-step pair, and you need both. Identification is when a subject claims an identity, like typing a username, swiping a smart card, or presenting a face to a scanner. Authentication is when the system verifies that claim against stored records, usually by checking a secret. A core rule is that every subject must have a unique identity. Picture arriving at a secure building. Stating your name is identification, but the guard still has to match your badge before the door opens. Why is a claimed identity worthless on its own? Because a name proves nothing without verification. Imagine a user types the username for an employee named John Doe but never enters a password. If the system lets him in on the name alone, it has no proof he is actually John. Anyone who learns that username could walk right in. And keep in mind, the secret used to verify identity must be protected. which is why passwords are stored as hashes, never as plain readable text. Does one authentication method fit every situation? No. And matching the method to the environment is the real skill. Every technique carries trade-offs, so you weigh strength against convenience for the setting. A facility handling highly classified material demands very strong, layered proof. A shared login for students in a classroom needs far less. And remember, these same methods do not only verify people, they also verify devices and services asking for access. What are subjects and objects? And why does the distinction matter? Access control is really about the relationship between two roles. A subject is the active party that reaches out to get information. An object is the passive party that holds or provides it. A quick shortcut is to read subject as user and object as file. But subjects also include programs, services, and computers. And objects include databases, printers, and processes. So the model is broader than just people opening documents. How can the same thing be both a subject and an object? Because the roles flip depending on who is asking. The active party is always the subject, and the passive party is always the object, but an entity can swap between them. Take a web application serving pages. When a user requests a page, the application is the object being queried. Then it becomes a subject, as it reaches out to grab a cookie and look up the user in a database. Finally, it flips back to an object as it delivers the finished page. How do you prove who someone is the very first time? This is identity proofing, and it happens before any account exists. For a new employee, human resources checks physical documents like a passport, a driver's license, or a birth certificate. Once the documents are verified as genuine, registration begins, which can be as simple as creating an account and setting a password. If the organization uses biometrics, registration also captures something like a fingerprint. Think of it as a notary confirming you are real before signing you into the system. How do online services prove identity for someone they never meet in person? They often use knowledge-based authentication. The service pulls facts about you from authoritative sources like credit bureaus, then asks questions only you should be able to answer, such as details about a recent car purchase or a past address. You usually get limited time to respond. Picture opening an online bank account. The bank quizzes you on your own financial history to confirm the person applying is genuinely you. What are cognitive passwords, and where do they fall short? Cognitive passwords are security questions, like your first pet's name or your mother's maiden name. Systems collect the answers at registration, then use them later to reset a forgotten password through self-service or a help desk. The problem is that this information often lives on social media or turns up in a simple search. If an attacker finds your answers online, they can hijack your password reset. This is exactly why modern guidance discourages leaning on these static questions. What do authorization and accounting add to the picture? These are the two elements that follow a proven identity. Authorization grants a subject access to specific objects based on that proven identity. So an administrator lets a user open certain files and not others. Accounting holds subjects responsible by auditing their actions, logging when someone reads, changes, or deletes a resource into an audit trail. And because the user was properly authenticated first, those logs provide non-repudiation. The person cannot credibly deny doing something the record clearly shows. Why does authorization vary while identification does not? Because identification is all or nothing, but authorization comes in shades. Either your credentials prove your claimed identity, or they do not, with no middle ground. Authorization, by contrast, spans a wide range. You might read a file but not delete it, or print a document but not manage the print queue. Administrators grant only the privileges each person needs to do their job, following least privilege. This matters even more for automated agents, where overly broad permissions can let a system take harmful actions on its own. How does accountability survive even when authorization fails? Here is a subtle but important point. Accountability depends on solid identification and authentication, but it does not depend on authorization. Once you have identified and authenticated a user, the logs can track everything they attempt, including reaching for resources they were never allowed to touch. So even a blocked attempt gets tied to a real name. Without credentials, everyone would be anonymous, and no log could ever say who did what. What are the 3 factors you can use to prove identity? There are 3 primary categories, and they climb in strength. Something you know is a memorized secret, like a password, a personal identification number, or a passphrase. Something you have is a physical object you carry, like a smart card, a hardware token, or a phone running an authenticator app. Something you are is a biometric trait, like a fingerprint, a face scan, or an iris pattern. Using a single one is single factor, while combining 2 or more different categories is multi-factor authentication. Knowledge is the weakest and biometrics the strongest, though even a fingerprint reader can be fooled by a molded fake. So let's bring it together. Identity and access management rests on 3 functions: authentication, authorization, and accounting. Identification and authentication pair up, so a subject claims and then proves who they are, and subjects act on passive objects. You establish identity through proofing, registration, knowledge-based checks, and cognitive passwords. Authorization decides what a proven identity may touch, while accounting logs it all for non-repudiation. And you prove identity with 3 factors: something you know, have, and are. Lock these foundations in, and the rest of the model builds cleanly on top. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session. Welcome to Section 13.2, Part 2. This is the 144th session of the CISSP Exam Prep series. This part digs deeper into the specific factors and secrets you use to prove identity. In this session, we'll get concrete about the tools of authentication. We'll answer several questions. How can location itself become a security signal? What is the something you know factor? And why are passwords so weak? What makes a strong password policy? What do the leading authorities recommend? What is the something you have factor? And how does the something you are factor use biometrics? Why does this matter beyond the exam? Because you make authentication choices for real people every week. Imagine rolling out access for a distributed sales team that logs in from airports, hotels, and home offices. Some of your controls will lean on where they are, some on what they remember, and some on what they carry or who they physically are. Knowing the strengths and weak spots of each lets you build a login that is both secure and livable. How can location itself become a security signal? Location adds attributes that back up the main factors. One is somewhere you are, which ties a login to a specific place, an IP address, or a phone number from caller identification. Its flip side is powerful for catching fraud. If a user normally signs in from Virginia Beach and a login suddenly appears from overseas, the system can block it even with the right password. It is not perfect though, since an attacker can route through a virtual private network to fake the source. Picture a card that only works at your usual coffee shop and refuses a charge from another continent. What is context-aware authentication, and what is something you do? Context-aware authentication checks several signals at once, common in mobile device management. It weighs the user's location, the time of day, and the specific device before allowing a normal login to proceed. If all the conditions fit, the user continues with their username and password. There is also a lighter idea called something you do, like tracing a pattern across a grid or swiping across a chosen picture to unlock a screen. Think of it as a secret handshake your fingers perform. What is the something you know factor, and why are passwords so weak? The classic example is the password, a static string you memorize. Passwords are the weakest form of authentication for a stack of reasons. Easy ones are simple to guess, hard ones get written down, and users share them or forget them. Attackers steal them by watching, sniffing networks, or dumping databases, especially when passwords travel in clear text or sit in exposed storage. And they fall to attacks like brute force guessing, dictionaries, password spraying, and credential stuffing. Treat a lone password like a house key hidden under the doormat. How do you make a memorized secret stronger? You reach for a passphrase. A passphrase is a longer string that carries personal meaning, like a short sentence about earning your certification. run together without spaces if the system rejects them. It is easy to remember yet hard for a brute force tool to crack, and it steers users away from predictable choices like the word password or a simple number run. Personal identification numbers also live in this factor, typically 4, 6, or 8 digits. A passphrase is like a full lyric, only you would think of far tougher than a single word. What makes a strong password policy? Organizations write a password policy and enforce it with technical settings. Maximum age forces a periodic change, sometimes called expiration. Complexity sets how many character types are required, from lowercase and uppercase to numbers and symbols. Length sets the minimum number of characters, and longer is always harder to crack. Minimum age blocks changing a password again too soon, and history remembers past passwords so users cannot cycle back to an old favorite. Together, minimum age and history stop someone from rotating straight back to the password they started with. What do the leading authorities recommend for passwords? Guidance is shifting, and two sources stand out with different advice. The first, from the National Standards Institute, breaks with older habits. It says hash every password and never store or send it in clear text. It says stop forcing routine expiration, since users just bump a number and gain nothing. It drops mandatory special characters, lets people paste from a password manager, allows all characters including spaces, and asks for a length from 8 up to 64. It also says screen new passwords against lists of common ones. The second source, the payment card security standard, is stricter. It expires passwords at least every 90 days, requires at least 12 characters, demands both letters and numbers, and blocks reuse of the last 4. When you must meet a standard, follow at least its minimums. What is the something you have factor? This factor is a physical object you carry, and it shines when paired with another factor for multi-factor authentication. A smart card is a badge-sized card with an embedded chip, often holding a microprocessor and certificates used for encryption or digital signatures. It is tamper-resistant and a tidy way to carry complex keys. But because cards can be swapped or shared, you usually add a personal identification number or password alongside it. Think of the card as a key fob that only truly works once you also punch in your code. How do authenticator tokens generate one-time passwords? An authenticator is a device or app that produces a short one-time password, and a matching server always knows the current value. You typically enter your username and password, then add the number from the authenticator, giving multi-factor strength. There are 2 flavors. A time-based one changes the code every so often and depends on the device and server sharing a synchronized clock, so it is called synchronous. A counter-based one uses an incrementing counter instead of a clock and only advances when you press a button, so it is called asynchronous. The catch is real-world fragility, since a dead battery, a break, or a lost device locks you out. Why has text message 2-step verification fallen out of favor? Sending a one-time code by text message is better than a password alone, but the Standards Institute has deprecated it for federal use. Phones show text on the lock screen, so a stolen device hands the code straight to a thief. Worse, an attacker can trick a mobile carrier into redirecting your messages, sometimes through fraud that hijacks your subscriber identity module card. Picture a mailbox with no lock where anyone glancing over can read your one-time codes. How does the something you are factor use biometrics? Biometrics measure physical traits and can serve as identification, authentication, or both, though they never provide authorization or accountability. Used for identification, the system searches your offered pattern against a whole database of enrolled users. Used for authentication, it does a one-to-one match against the single stored pattern for the identity you claim. So one mode asks, "Who is this?" and the other asks, "Are you really who you say?" It is the difference between scanning a crowd for a face and confirming the one face at the turnstile. What are the main physiological biometric methods? Several traits get measured, each with its own trade-offs. Fingerprints read the unique loops, halls, and ridge details on a finger and show up everywhere, from laptops to security keys. Face scans map the geometry of a face to unlock devices or screen people at borders. Retina scans read the blood vessels at the back of the eye and are the most accurate, but they can reveal medical conditions and demand you get very close. Iris scans read the coloured ring around the pupil, nearly as accurate and workable from a distance, though a sharp photo can sometimes fool them. Palm scans use infrared light to read vein patterns in the hand, and voice recognition matches the print of your speaking voice. Just do not confuse voice recognition, which tells one speaker from another, with speech recognition, which turns anyone's words into text. So let's bring it together. Location signals like somewhere you are, context-aware checks, and something you do all reinforce the main factors. Something you know covers passwords, passphrases, and personal identification numbers, hardened by sound policy and modern guidance. Something you have covers smart cards and authenticator tokens, while text message codes have lost their shine. Something you are covers biometrics, from fingerprints and faces to retinas, irises, palms, and voice. Understand each factor's strength and its weak spot, and you can design authentication that actually fits the people using it. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session. Welcome to section 13.2, part 3. This is the 145th session of the CISSP exam prep series. This part finishes the model by measuring biometrics and extending authentication to devices and services. In this session, we'll close out the model with accuracy and reach. We'll answer several questions. How do you measure whether a biometric device is accurate? What makes biometric enrollment practical or painful? Why is multi-factor authentication so much stronger? What is passwordless authentication? How do you authenticate a device rather than a person? How do services prove themselves? And what is mutual authentication? Why does this matter beyond the exam? Because modern access is not just people typing passwords. Imagine securing a hospital where staff badge in with fingerprints. Laptops must prove they belong on the network. A monitoring service scans mailboxes. And remote clinicians connect over an encrypted tunnel. Each of those is authentication of a different kind. Knowing how to measure and extend it lets you protect an environment that stretches far beyond a login box. How do you measure whether a biometric device is accurate? You look at the errors it makes. A false rejection happens when the system turns away a valid user, also called a false negative. And its measure is the false rejection rate, sometimes labeled a type 1 error. A false acceptance happens when the system lets in the wrong person, a false positive, measured by the false acceptance rate, a type 2 error. Most devices have a sensitivity dial. Turn it up and you get more false rejections. Turn it down and you get more false acceptances. Picture a smoke alarm. Too touchy and it screams at burnt toast. Too dull and it sleeps through a real fire. How do you compare one biometric device against another? You use the crossover error rate, also called the equal error rate. As you slide the sensitivity, the rejection rate and the acceptance rate move in opposite directions, and the point where they meet is the crossover rate. A lower crossover rate means a more accurate device, so it is the standard yardstick for comparison. But you rarely run a device at that crossover point in practice. To guard a secure vault, you crank sensitivity high to nearly eliminate false acceptances, accepting more annoying rejections as the fair trade. What makes biometric enrollment practical or painful? 3 human factors decide whether people accept it. Enrollment time is how long it takes to first capture the trait, and anything past roughly 2 minutes wears thin. Throughput rate is how long each later scan takes to approve or deny, and users expect something around 6 seconds or faster. Acceptance is simply whether people are comfortable using it at all. And if the trait drifts over time, like a changing voice, users must re-enroll periodically, which adds friction. Think of airport security. If the line crawls, people revolt no matter how good the technology is. Why is multi-factor authentication so much stronger? Because it forces an attacker to win several different fights at once. Multi-factor means using 2 or more different factors, like something you know plus something you have. The key word is different. 2 passwords are not multi-factor, since one crack could grab both. And combining a password with a personal identification number fails the test, because both are things you know. But pair a token, a password, and a fingerprint, and an attacker must pull off a physical theft, a password crack, and a biometric forgery all at the same time. It is the difference between one lock and three locks that each need a completely different kind of key. What is passwordless authentication, and where is it heading? It lets users log in without any memorized secret at all. Since static passwords are the weakest link and heavy policies push people toward risky workarounds, the industry is moving away from them. You already see it when a phone unlocks with your face or a tablet with your finger, and many apps then reuse that same proof to reach sensitive data. An open industry alliance has built standards to cut this reliance on passwords, centered on hardware passkeys you plug in or tap. Think of a passkey as a physical key that replaces the password entirely. Nothing to remember and nothing to phish. How do you authenticate a device rather than a person? You give the device its own identity. Traditionally, a company computer joins a domain and gets a machine account with credentials, and if those fall out of sync, no one can log in from it. For devices that cannot join a domain, one approach is device fingerprinting, where a user registers the device and the system records traits like its operating system, browser, fonts, time zone, and screen resolution. Later logins check those traits against the registered profile. Two more tools help here. Network access control systems check a device's health before granting access, and the 802.1x standard enforces port-based authentication on switches and wireless before a device even reaches the network. How do services prove themselves? Through service accounts and certificates. A service account is just a user account created for an application instead of a person, like an account for a tool that scans mailboxes for threats. Some come built in with sweeping privileges, which is why attackers probe for weak or blank ones. Because these accounts are powerful, you give them strong passwords, change them more often, set them so passwords never expire since a service cannot answer a change prompt, and make them non-interactive so no human can log in through them. Services can also present certificates issued to the device, and web services often authenticate through application programming interfaces, which differ from one provider to the next. What is mutual authentication? And when do you need it? It is two-way proof, where both ends verify each other before trusting anything. Instead of only the server checking the client also checks the server, usually by exchanging digital certificates. This stops a client from spilling information to an imposter server. Picture an employee connecting home to work over an encrypted tunnel. Both the client and the server present certificates, and if the check fails because traffic was steered to a rogue server, the session simply never starts, and the employee never hands over their credentials. So let's bring it together. You measure biometric accuracy with false rejection and false acceptance rates compared at the crossover error rate, and you keep enrollment fast enough for people to accept. Multi-factor authentication wins by demanding different factors at once, and passwordless approaches with passkeys are replacing fragile secrets. Authentication reaches past people to devices through fingerprinting, network access control, and port-based standards, and to services through service accounts and certificates. And mutual authentication makes both ends prove themselves. With that, the full model is complete. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session. Welcome to section 13.3. This is the 146th session of the CISSP Exam Prep series. In this session, we'll see how identity management is actually built. We'll answer several questions. What is the difference between centralized and decentralized control? How does single sign-on work? And what does it risk? How do directory services and trusts fit in? How do federated identities extend trust across organizations? Where can a federation live? What is just-in-time provisioning? How do credential management systems help? And how do you keep idle sessions from becoming a whole? Why does this matter beyond the exam? Because these are the plumbing decisions that shape daily access. Imagine two firms merging, each with its own login system, now needing staff to reach both without juggling two passwords, or a company sending employees to a cloud training portal it does not run. Every one of these calls for a design choice about where identity lives and how trust travels. Make good calls here, and access feels seamless while staying controlled. What is the difference between centralized and decentralized access control? It comes down to where the authorization decisions happen. Centralized control puts a single authority in charge, so a small team or even one person manages it, one change ripples everywhere, and overhead stays low. The catch is a single point of failure. Centralized systems also scale well, adding capacity as you grow. Decentralized control spreads decisions across many points, needing more people and more effort, since every change must be repeated everywhere and consistency gets harder. Think of one master key desk versus a building where every floor manages its own locks. How does single sign-on work, and what does it risk? Single sign-on is a centralized technique where you authenticate once and then reach many resources without logging in again. It is convenient, and it quietly improves security, because users juggling a dozen passwords tend to write them down, while one strong password is easier to protect. It also cuts the number of accounts an administrator has to manage. The trade-off is concentration of risk. If that one account is compromised, the attacker inherits everything it could reach, which is why these systems layer on extra protection for the credential. Think of it as a single hotel keycard that opens your room, the gym, and the pool. Convenient until someone steals the card. How do directory services and trusts fit into all this? A directory service is the centralized database that often powers single sign-on inside an organization. Many are built on the lightweight directory access protocol, and you can picture the directory as a phone book for network resources. Users and processes search it to find where something lives, but they must authenticate first, and even then it reveals only what their privileges allow. Larger environments split into security domains, each a set of subjects and objects under a shared policy. Trusts then bridge those domains so users in one can reach resources in another, and a trust can run one way or both ways. That same directory protocol also serves a public key infrastructure, letting clients query a certificate authority about a certificate. How do federated identities extend trust across organizations? Single sign-on is easy inside one company, but federation stretches it across many. A federated identity management system links your identity in one place with your identities elsewhere, and multiple organizations can join a federation where they agree to share identity information. You log in once at your own organization, your credentials map to a federated identity, and that identity gets you into resources at other members without logging in again. Crucially, joining a federation does not hand everyone the keys to everything. Each organization still decides exactly what it will share, and the matching happens quietly in the background. Picture a group of partner airlines that honor each other's loyalty status without making you re-enroll. Where can a federated identity system actually live? It can run on-premises, in the cloud, or as a hybrid of both. A cloud-based federation uses a third-party service to share identities, which is common when a company sends staff to an external training site and coordinates the federated access. An on-premises federation keeps everything in-house, ideal when two merged companies want to share authentication data across their own networks while keeping maximum control. A hybrid stitches the two together, connecting an existing on-premises setup with a cloud service so users on either side still get single sign-on. Think of it as choosing whether the shared guest list is kept at your front desk, at an outside agency, or split between both. What is just-in-time provisioning? It is a way to create the account only at the moment it is first needed, with no administrator lifting a finger. Some federated solutions support it, automatically building the link between two parties so a new user just works. Say a company contracts a third-party benefits portal. Rather than pre-creating an account for every employee, the system waits. The first time an employee visits the portal, it confirms they are logged into a trusted network, then exchanges details like name and email to create the account on the spot, often using a shared markup language for that handoff. Picture a conference badge that prints itself the instant you walk up, instead of someone preparing thousands in advance. How do credential management systems help users and developers? They provide safe storage for usernames and passwords so people are not reinventing the wheel. Web browsers do this using a standard credential management interface, offering to save credentials, showing a chooser, and logging you back in automatically. Some federated solutions build on this so you can sign into one service using an account from another provider. There is also Identity as a Service, a third-party offering that delivers identity and access management. effectively bringing single sign-on to the cloud. It shines when internal users need to reach cloud software, letting them authenticate once and move between many cloud applications. What about dedicated apps and password vaults? These store credentials locally under strong protection. A built-in credential manager can encrypt and save what you enter, then return it when you revisit a site or app. Third-party password vaults go further, keeping credentials in an encrypted database that you unlock with a single master password, after which you can copy or autofill them. The whole scheme rests on that master password being strong, since it guards everything else. There is also scripted access, where a logon script feeds credentials automatically to simulate single sign-on in environments that lack the real thing. But because those scripts often hold credentials in clear text, you must store them in a protected location. How do you keep an idle session from becoming a hole? You manage the session so it does not stay open unattended. On desktops and laptops, a password-protected screensaver kicks in after a set idle time, often 10 to 20 minutes, forcing the user to authenticate again. Online sessions work the same way, logging you off after a period of inactivity, sometimes with a warning you can dismiss to stay in. Behind the scenes, developers lean on web frameworks that mint a session identifier at the start, carry it through every request, and can wrap the whole session in transport encryption. Those frameworks also expire sessions, with high-value applications timing out in just a few minutes, while low-value ones allow longer. Think of it as a bank teller window that locks itself the moment you step away. So let's bring it together. Centralized control is simple, but risks a single point of failure, while decentralized control spreads the load and the effort. Single sign-on gives one login to many resources, powered by directory services and trusts, and federation carries that convenience across organizations, on-premises, in the cloud, or hybrid. Just-in-time provisioning creates accounts on demand, credential systems and vaults store secrets safely, and disciplined session management closes the door on idle access. Together, these are the building blocks of real-world identity management. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session. Welcome to section 13.4. This is the 147th session of the CISSP Exam Prep series. In this session, we'll follow an account from birth to retirement. We'll answer several questions. What is the identity and access provisioning lifecycle? How do you provision and onboard a new hire? How do you deprovision and offboard someone who leaves? Why do roles need careful definition? What does ongoing account maintenance involve? And why do access reviews catch problems nothing else does? Why does this matter beyond the exam? Because accounts are where access quietly goes wrong over time. Picture a fast-growing retailer hiring, transferring, and losing staff every week. Without a disciplined life cycle, ex-employees keep active logins, transferred staff pile up permissions, and nobody notices until an audit or a breach. Managing this life cycle well is unglamorous, but it is exactly where real-world access control lives or dies. What is the identity and access provisioning life cycle? It is the full arc of an account. Its creation, its management, its review, and its deletion. These steps feel routine, but they are the backbone of access control. Without accurate accounts, a system cannot establish identity, authenticate, authorize, or hold anyone accountable. And remember, this covers more than people, since computers and services also carry accounts. Think of it like the life of an employee badge. Issued on day one, updated as the job changes, and collected on the way out. How do you provision and onboard a new hire? Provisioning creates the account and grants exactly the privileges the new role needs, following a defined procedure rather than someone's whim. Creation, sometimes called enrollment, starts with a unique identifier and adds details like full name and email, plus biometric data if that is used. It is critical to prove the person's identity first, through documents, background checks, or reference checks. Many organizations automate this, so human resources triggers the request and the system builds the account by consistent rules, even placing the user into the right groups so privileges come along automatically. Provisioning also means issuing hardware like laptops and authenticators with careful records. Onboarding then follows, covering the acceptable use policy, security basics, and getting the person productive. Picture a new hire's first day, badge printed, laptop handed over, and the ground rules explained. How do you deprovision and offboard someone who leaves? You reverse the process, whether they quit, are laid off, or are terminated, and the same steps apply to transfers. The simplest deprovisioning is deleting the account, but that can also destroy access to the person's own data, like an encryption key only they held. So many organizations disable the account instead, letting a supervisor recover anything needed before deleting it, often within 30 days. Speed matters, because a terminated worker who keeps access is a real sabotage risk, and a lingering account could be misused under the wrong person's name in the logs. Offboarding also means collecting issued hardware and stopping benefits, since a missed benefit can quietly cost real money for years. Think of it like recovering the badge, the laptop, and the keys the moment someone walks out. Why do roles need careful definition and transition? Because responsibilities change constantly. Sometimes a simple transfer and sometimes a brand new job function. When a new role appears, you define both the role and the privileges anyone in it should have, then decide how to assign them, usually through groups. Say a company launches an online store on a new server, needing developers and system administrators it did not have before. You create those roles, spell out their required privileges, and map them to groups so assignment stays clean. And when a person moves between jobs, their group membership should move with them. Picture rewriting a job description and then handing over exactly the keys that role requires, no more and no less. What does ongoing account maintenance involve? It is the steady upkeep of rights and privileges across an account's whole life. Organizations with stable structures and low turnover need far less of this than fast-changing ones with heavy promotion and movement. Most of the work is adjusting access, and it deserves the same disciplined procedures you use when creating accounts, because an unauthorized bump up or drop in privileges can cause serious harm. Think of it like regular maintenance on a vehicle. Small, consistent attention that prevents a major failure later. Why do account access reviews catch problems nothing else does? Because they periodically check every account against what it should have. Administrators review user, privileged, system, and service accounts to confirm none carry excessive privileges and all comply with policy. Watch the local system account especially, since it often has broad power and sometimes doubles as a service account, handing an attacker a wide opening if the application is exploited. Automation helps, with scripts finding accounts idle past 30 days and disabling them, or scanning privilege groups for accounts that do not belong. Privilege monitoring keeps a close eye on anything with elevated rights. What two access problems do these reviews hunt for? They target excessive privilege and privilege creep. Excessive privilege is when an account simply holds more than the job requires, and the fix is to revoke what is not needed. Privilege creep is subtler, where permissions pile up over time as someone changes roles. Imagine a worker moving from accounting to sales who gets the new sales rights but keeps the old accounting ones. Now she can reach far more than her job calls for. Both problems break the principle of least privilege, and regular access reviews are the tool that reliably surfaces them. Think of it as spring cleaning for permissions, clearing out what should have been let go long ago. So let's bring it together. The provisioning lifecycle runs from creating an account, through managing and reviewing it, to deleting it. You provision and onboard by proving identity and granting just the right access. And you deprovision and offboard by disabling accounts, recovering hardware, and cutting benefits. You define roles carefully, maintain privileges with discipline, and run access reviews to catch excessive privilege and privilege creep. Handle this lifecycle well, and access stays aligned with need from a person's first day to their last. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.